Pulsar from Qubit Electronix is a unique 4-channel gate pattern sequencer. Qubit was kind enough to send one over for investigation, and it's been a lot of fun. Pulsar features 4 independent channels of up to 16-step sequences, selectable using the channel button. An additional output is dedicated to the internal clock, which can be set from 5 milliseconds to 16 seconds between pulses by holding channel and turning the rate clock knob. Each channel has an independent clock divider and multiplier, accessed by simply turning the rate clock knob while on that channel. Or any channel can be detached from the main clock to run independently by simply pushing the rate clock encoder. The mode knob selects between 4 different pattern sequencing modes, starting with the sequencer mode, when the upper left-hand quadrant of LEDs is lit. Euclidean rhythms for the upper right-hand section, binary digit patterns in the lower right-hand section, and randomized patterns in the lower left-hand zone. Sequencer mode is the first mode, offering an assignable gate pattern with adjustable length. Simply turn the main encoder to select a step and then pushing the encoder to enable or disable that step to create a pattern. Push the encoder in and hold, then turn to offset the pattern. The length knob can be adjusted to set the pattern length from 1 to 16 steps, indicated by the LEDs, or to play back in reverse by turning the knob left beyond the 1-step setting, illuminating the ring in the opposite direction. Pushing the length knob enables and disables pattern looping, allowing for one-shot firing of the sequence using the burst button or CV input. Which can be particularly interesting with gravity enabled to create a bouncing ball effect. Euclidean Mode is an accessible Euclidean rhythm generator, a tool for evenly displacing a number of notes over a set of steps. Set the pattern length using the length knob, and turn the main encoder to increase the number of hits or fill notes divided up across the pattern. The third critical factor with Euclidean rhythms is pattern offset, which is as easy as pushing and holding the encoder, then turning it. This is a particularly fun implementation of Euclidean rhythm performance too. Binary mode incrementally counts in binary numbers as the main encoder is turned, counting up when turned right and down when turned left. The LEDs represent binary values, starting with 1, 2, 4, 8, 16, 32, 64, 128, to a total of 65,535. Offset is key for this mode, since turning the knob to get higher values would take ages. By offsetting a small value, we can shift it to a much higher number. Then, slightly changing it will generate lower value bits, resulting in a more complex pattern. Random mode creates random sequences, with increasingly more steps added to the sequence as the main encoder is turned to the right. Slowly adding random steps or slight changes up or down can give the effect of an evolving sequence. We'll look at some more of the experimental functions and global control of Pulsar in a future video. How are you generating gate sequences and interesting rhythms? Tell us about it in the comments. Thanks for watching and sharing. As always, please like, follow, and subscribe. And remember, patch smarter.